One of the places people tend to get hung up is when they're trying to rearrange an equation that has a lot of variables. And there's two rearrangements that you might have for this equation. The first one is you may need to solve for d. In solving for d, d is on the bottom here, and you can't do anything to solve for it as long as it's on the bottom. So the first thing you'll do is you'll multiply both sides by d squared. And in doing that, you're going to cancel out the d squared on this side, and you're bringing it to the other side. That's going to give you that d squared times fe equals k times q1, q2. Keeping the d squared on this side now is what you'll do because it's up top, and you want to move the force to the other side. So for this step, you'll divide by the force of both. You'll always do the opposite of what's already happening. So currently it's being multiplied, opposite of that is dividing. And you're left then with that d squared is equal to k times q1, q2 over your force. That's close, d is by itself, however it's not completely alone, it's still multiplied by itself. And so to change that squared and get rid of it, the opposite of that is to square root it, and you have to do that to both sides. In doing that, you're getting rid of that squared, and you're left with that d is equal to k, q1, q2 over f of e, and the square root of that whole thing there. So you'll calculate that number and then take the square root of that whole thing. The other type of rearrangement you might have is solving for one of the charges. Again, you're starting with the same equation. Fe is k, q1, q2 over d squared. And it doesn't matter if you're solving for q1 or q2. It'll still be the same process. And in doing that, the first thing you need to do, you'll start the same as you did before, d squared on both sides, and that brings that up top. You don't want to keep that in the bottom while you're trying to move other things up top. So when you do that, you end up with d squared times f of e equals k times q1 and q2. Well, k and q1 and q2 are all multiplied together right now, and so the opposite of that is dividing it. So let's say I'm solving for q1. I would divide by k and q2, and I'll do that on both sides, k and q2. Cancels out the k's here and the q2's there, and it leaves me with the equation that q1 is equal to d squared times the force, that electric force, over k and q2. Now the thing that you need to be thoughtful of when you're putting this into a calculator is how you divide this at the bottom. Let's say I have some numbers and I'm going to put them into the calculator. Let's say, just for example, let's say that we're going to use the distance is 0.12 and the force is 1.7 newtons. And then I would hit divide, and then you have to make sure that the bottom part stays together. So you put your parentheses, you'd put your k number, 8.99 times 10 to the negative 9th, and then you would multiply and just use the times sign. Don't use a bunch of parentheses like I showed here. And then let's say q2 is 6.7 times 10 to the negative 6th, and then parentheses. When you do that, it takes and it multiplies these first, it multiplies these, takes this divided by that whole thing. If you don't keep the parentheses on the outside when you put it in your calculator, it'll take this, it'll divide by that, and it'll get an answer. And then it'll take that answer and multiply by that. And while your numbers will line up to be similar, they might end up, your scientific notation will end up being off. Sometimes your numbers are off as well. So double check, if you're not getting the answer, double check that you're putting parentheses on the bottom to get what you need in those situations.